Good morning, Chem 1 students. Today, we are going to have a discussion about converting using Avogadro's number. So, ladies and gentlemen, our objectives are to, number one, be able to convert from moles to particles using Avogadro's number. Our second objective is the vice versa of that, to convert from particles to moles using Avogadro's number. So we're going to go two different ways. We're going to go from moles to particles, particles to moles. So we're going to start off real simple. And I'm just going to work a conversion right here, okay? And it says, nice and easy. We've been talking about, amount of a substance being the mole. Well, we compared that to a dozen. So I'm going to do a nice, easy conversion here using a dozen. Now, it says, how many donuts are in 3.5 dozen donuts? Well, what I'm going to do is I'm going to take what I know. And I know that I have 3.5 dozen donuts. Now I'm going to set up a conversion box. And in my conversion box, on the top part, I'm going to put what I am trying to convert to. So, I'm trying to convert to donuts. Okay? I'm trying to convert from to donuts, and I have 3.5 dozen. Well, I know that 1 dozen is 12 donuts. 1 dozen is 12 donuts. I'm going to make sure that my label cancels. So here's a dozen on the top. Here's a dozen on the bottom. Now why, ladies and gentlemen, why does that cancel? Well, let's go down here a little bit. What is a dozen over a dozen? Well, anything over itself is equal to 1. So 6 over 6 is equal to 1. 4 over 4 is equal to 1. So a dozen over a dozen is equal to 1. So my labels cancel. What does that leave me with? It leaves me with donuts. So what I'm going to do is everything on the top I multiply and then I divide by the bottom. So what I'm basically doing is I'm taking 3.5, timesing it by 12, and then I'm going to take that value and do that first, and then I'm going to divide it by 1. When I do so, I take 3.5, I multiply that by 12, and I get 42. So my label is going to be right here. I'm going to bring my label down, 42 donuts. Box my answer so Mr. Braun knows where my answer is. Therefore, 3.5 dozen donuts is equal to 42 donuts. Excuse me. Now, what does donuts have to do with chemistry? Well, not really anything. But we talked the other day about moles and Avogadro's number. And we stated that 1 mole of carbon has Avogadro's number of atoms of carbon. 1 mole of glucose, and look, glucose is covalently bonded, so we're going to have Avogadro's number of molecules. Okay. 1 mole of sodium chloride. Sodium chloride is ionically bonded. Therefore, we're going to have Avogadro's number of formula units. So, when we're talking about these particles, okay, when we're talking about these particles, we can have 3 different labels. They are atoms, molecules, formula units. Okay? Atoms, molecules, and formula units. Now, let's just jump right in to this little guy here. And this guy, I'm going to give you a second to write this down into your notes. So go ahead and pause the video and write this down into your notes, this whole thing. Okay, ladies and gentlemen, today we are going to be dealing with just this bottom section, okay? Just this bottom section right here, that one. So we're going to go from moles to formula units, and formula units, or excuse me, moles to particles, and particles back to moles. So when we are doing so, we have conversion factors, just like the 1 dozen is 12 donuts. Well, if I have representative particles and I want to go to moles, my conversion box is going to have mole, 1 mole on the top, and it's going to have Avogadro's number on the bottom. And I'm just going to put particles because it can have any of the 3 labels. And just like that, if I'm going the other way, if I'm having the mole, okay, if I'm having the mole and I want to go to the particle, it's going to be this side. So the bottom is going to be 1 mole, and the top is going to be Avogadro's number. And once again, that's going to be particles. So, when I come in and I do my very first example, I read, and it says, how many atoms are in 0.909 moles of silver? Well, as I go back to my flux capacitor, I have moles of silver, right? So I'm starting right here with the moles, and I want to go to atoms. So I'm going to go down here. I'm going to follow that green arrow. So my conversion is going to be Avogadro's number of particles over 1 mole. So as I come back to my problem, I see, I write out that I have 0.909 mole of silver. Silver is Ag. Okay? Once I do my conversion factors, I set up my conversion box, I want mole of silver to cancel. So I'm going to put that mole of silver on the bottom so that it cancels. And on the top, I want to go to atoms of silver. So I'm going to put Avogadro's number of atoms of silver. Once I've done that, my moles should cancel, and that leaves me with my answer being in atoms of silver. So all I simply need to do is I need to take 0.909 and multiply that by Avogadro's number and execute that, and I get the answer. And first thing, my answer I need to have in 3 sig figs. Oh boy, Braun, here we go again with the sig figs. Yep. I go back to the original problem. I don't use Avogadro's number, the original problem that was given, and I have 3 sig figs. So my answer is going to have 3 sig figs. My answer then will be 5.47 times 10 to the 23rd atoms of silver. Once again, I box it so Mr. Braun knows where my answer is. Okay, 5.47 times 10 to the 23rd atoms of silver. And that is equal to 0.909 moles. My next example. How many molecules are in 3.944 moles of ammonia? Once again, if I'm picturing my flux capacitor, like you have in your notes, I'm going from the center moles to the bottom right, which is molecules this time, because I'm dealing with ammonia covalently bonded. So 3.944 moles of ammonia. I set up my conversion box. I know that I want moles of ammonia to cancel. Well, I know that 1 mole of ammonia has Avogadro's number of molecules. Oops. Of molecules of ammonia. I do indeed get my moles to cancel. That's going to leave me with my answer to be molecules this time. Molecules of ammonia. So I'm going to take the 3.944 and I'm going to multiply that by Avogadro's number. I can see that this has 4 sig figs, so my answer is going to have 4 sig figs. So my answer is going to be 2.375 times 10 to the 24th. Okay? 2.375 times 10 to the 24th molecules of ammonia. Final answer. Now, one thing that we need to remember when we're reading our calculator, a lot of people forget to put that e to the 24 there. On my calculator, it gave me this number, and then it says just a E24. Now, people miss that E24, and they'll write this number as 2.375 molecules of ammonia. That is not a correct statement. So make sure you have that scientific notation in there. Now, we're going to work one the other way here. And it says, how many moles are in 2.38 times 10 to the 26 formula units of strontium nitrate? Love it here. Love it here. I don't necessarily need it yet, but, okay, I need to know strontium nitrate. Well, strontium is an alkaline earth metal. It's in group 2. Okay, so when I'm writing out strontium nitrate, I have SrNO3 2. So I love doing this because, once again, here we go. If we can't name this, we're going to run into problems. All right, once again, I'm going to start with what's given. 2.38 times 10 to the 26 formula units of strontium nitrate. I'm going to do my conversion box. Okay, I'm going to do my conversion box, and this time it's going to be a little bit different. It's going to be a little bit different because I can see my flux capacitor. I'm going from representative particles down on the bottom right up to formula units, which is in the middle. So when I do that, I'm going to put Avogadro's number, and that's going to be formula units of strontium nitrate. And on top, I'm going to put 1 mole of strontium nitrate because I know that Avogadro's number of formula units is equal to 1 mole. My formula units here are canceling, so my label is going to be mole of strontium nitrate. Okay? And all I have to do is my math. Well, as I told you before, I multiply everything on the top. So I'm going to take 2.38 times 10 to the 26, and I'm going to multiply that by 1. Well, I don't really need to do that because I know it's going to give me the same value. So after I've done that, multiplied that by 1, I am going to divide by Avogadro's number of particles, 6.022 times 10 to the 23rd. When I do my math, I am going to come up with a value, and I go back to my original problem, 1, 2, 3 sig figs. I'm going to come up with a value of 395 moles of strontium nitrate. Put my box around it so Mr. Braun knows where my final answer is. And there you have it. Ladies and gentlemen, this is Mr. Braun. We've been dealing with converting using Avogadro's number. We'll go over some review notes tomorrow on this. Okay? But, ladies and gentlemen, have a fabulous day.